And good evening, everybody, and welcome to Online Prep Live from ACT and Kaplan. My name is Arthur. It's my pleasure to be with you all this evening for our introduction into the ACT math test. We've got an exciting hour and a half of programming tonight. I'm very glad that you've spent your part of your evening with us to log in and check out some of the great learning that we're going to do together in terms of understanding how the ACT math test works. I'm very happy to see so many of you. And by the way, just a couple logistical notes just to get us started. To my right, you should see a chat function there. You can use that chat function, and later on when we go through practice questions, I'll remind you guys to click on the poll section to answer some of the questions that we're going to cover together today. I am joined by an all-star team of Kaplan experts. We've got Boris, we've got David, we've got we've got Katie, and we've got Stephanie, all working very hard behind the scenes to help out with any questions that you might have. So that's one of the great things about online classes, especially what we do at Kaplan, is we encourage you all to ask questions if you have them. There's none of this like pausing. There's none of this like, oh, I have a question, but I don't know if I want to ask this. So if you do have a question, please post it into the chat, and also interact with us, interact with me, answer the questions that I'll be asking during tonight's session. I know a lot of you guys were here yesterday for the first session with Eli. I hope you guys had a great time with him. He's a very good friend of mine here at Kaplan, and also one of our very best ACT instructors. So I'm glad you had a chance to meet him, and you guys will see him actually tomorrow as well, and then I'll rejoin you guys on Thursday. But for now, let's get started with what we're going to look at today in our introduction to ACT math. So the ACT math test obviously covers a lot of material, a lot of different topics. So we may not get to every single topic, quite honestly. We're not going to get to every single topic tonight, but we're going to set a great foundation for you all so that by the end of this lesson, you have the basics down, so that you have that foundation where you can build, right? Like, you want to make sure that foundation is strong so that you can keep building and building and building. So tonight, it's all about manipulating linear and quadratic equations, about those annoying questions that deal with proportions and ratios and rates, so that when you have those questions that are asking you to find the unknown value, how can we solve those as quickly and effectively as possible? Look at questions that deal with the area of various polygons and circles. And lastly, we're going to use the properties and relations of geometric shapes to calculate unknown values. So when you have those questions that deal with different types of geometric shapes, maybe the ones that you're not quite so used to, we're going to look at the different properties to help you break down those questions. I hope you guys are excited. I'm super excited. Before we get into math content, just a quick refresher about the exam itself. Remember, the math test is always the second test on the ACT, and the math test is 60 minutes long, and there are 60 questions. So pop quiz, just to get us started here, a little bit of a brain warm-up for us all. Put it into the chat. About how much time is that per question? Approximately how much time is that per question? And I see, of course, right? Duh, 60 minutes, 60 questions. Yeah, 1 minute per question. And that'll come in really handy just to remember that you've got to move quickly through this test. And I saw from the poll that before we even got started that most of you are taking the ACT in October. So that means you've got a little bit less than a month, basically, or around a month to really think about how you're going to do well on the ACT. So knowing the format, knowing the content, knowing the different ways that ACT math questions are tested, these are the things that are going to help you succeed, not just on the ACT, folks, but for college, because the ACT is really about seeing how ready you are for college. And I'm going to take a wild guess here, and you can tell us in the chat which college or which university you're thinking of going to. Show some school pride here, but you're taking the ACT not for fun. You're taking the ACT not purely for fun, at least, but you're taking the ACT to show those colleges, look, I'm a great student. I've worked hard during my 4 years of high school, and I want to get into the best college possible for me. So that's why we're here to learn how to excel on the ACT. So 60 minutes long, 60 questions, and the math test has 8 different categories. So the ACT basically breaks down each math question into these categories, and you see those listed there. And again, notice here, a lot of you folks have probably started studying like higher level math, like for instance, maybe lots of trigonometry, maybe pre-calculus, maybe calculus even for some of you. But here, notice we don't mention calculus, we don't mention pre-calculus, we mention algebra, we mention geometry, we mention functions, because this is what the ACT is testing. Not just purely about the math concepts, but basically saying, hey, if you have a limited amount of information, what else can you find? That's what the ACT math test is really all about. Using math skills to test you on that particular skill. If you have a limited amount of information, what else can you figure out? Those are your 8 different categories. And do not worry, because ACT Kaplan Online Prep Live, our great program here, has lessons on every single topic. So we're going to go through just a handful of the topics tonight, but our full program, you will see every single topic to prepare you for the ACT. I hope that sounds good. Let's take a look at our first key concept dealing with algebra. So back to basics, just remembering the things that you've learned from way back in school so that you can go into this test confidently. First thing we want to recall is that every equation can be solved by working systematically. So the one thing to remember is whenever you are manipulating an equation, right, you're subtracting 3 on the left side, got to remember to subtract 3 on the right side. Or when you're dividing by 2 on the left side, got to remember to divide by 2 on the right side. Do the same thing to both sides of the equation. And if you remember the good old mnemonic, you can type in the chat how you've memorized this mnemonic before. I mean, this is not even high school math, folks, right? This is like from even before that, right? But the good old mnemonic of PEMDAS, please excuse my dear Aunt Sally. It's always Sally, right? Why can't it be Stephanie? Why can't it be Stephanie, right? We've got ACT teacher Stephanie with us, so maybe we're going to change it up later on. But this is the order of operations. Parentheses first, then exponents, then multiplication and division. Remember that those two go together left to right. And then addition and subtraction, those two go together left to right. Okay, so that's PEMDAS, just as a quick review. And lastly, the distributive property. When you have stuff inside of parentheses, separated by an addition or subtraction sign, and something outside the parentheses, use the good old distributive property to simplify that expression by multiplying what's outside the parentheses by everything inside the parentheses. So A parentheses B plus C leads us to AB plus AC. Let's take a look at our first question. We're going to open up the poll for this one. So if you have an idea what the answers are as we're working through the question, if you have an idea what the answers, click on the poll tab that you see on the right side, and then you click A, B, C, D, or E to see which to select your answers. Let's take a look at this question here. The equation 3z minus parentheses z over 2 plus 5 equals 10 is true when z equals which of the following values? So here, even though the wording is a little bit abstract or a little bit, maybe not quite as direct as you might be used to, this question is basically asking for what? It's asking for what's z? What the heck is z? What is z equal to? So we're going to solve that equation by first. Here's our original equation. And the big thing, and type this in the chat if you notice it, when you've got the negative sign outside of the parentheses, what's the thing you gotta remember to do when all parts inside that parentheses? Because this is the thing that throws off even the best test takers. This is the thing that throws off even the algebra experts sometimes. And you got to remember, seeing a lot of those comments coming in now, that when you have a negative sign in front of parentheses, you got to change the sign of everything inside the parentheses. So it's going to be 3z minus z over 2 minus 5. That positive 5 becomes negative. And from here, we can move the 5 over to the other side by adding 5 to both sides of that equation. So if 3z minus z over 2 is equal to 15. Now the next step here is, if you notice, we've got that fraction on the left side of the equation. So when you're combining fractions, you might remember this from old school math. When you're combining fractions, you want to find the common denominator. So the common denominator in this case is going to be, well, 3z is just the same as 3z over 1. And z over 2, the denominator there's 2. So we're going to get everything into a denominator of 2. Type it into the chat. What's that left side? What's 3z going to be equal to when we put that over 2? Instead of just saying 3z, what's that expression going to be when we say something over 2 on the left side? And that's going to give us, yeah, we see that that's going to give us 6z over 2 minus z over 2. And the reason why we want to make sure to have that common denominator is that when we have a common denominator, well, leave the denominators as they are and just combine the numerators. 6z minus z over 2 is 5z over 2, which is equal to 15. Now tell me this. Again, type it into the chat. What's our next step here? Now you've got one fraction on the left side and you've got an equation. So this is the big step here, right? Because remember, the goal here is to figure out what z is. So we want to get z by itself. What do we do here to get z by itself? And what we do here is we're going to multiply that denominator by 2. Basically, get rid of the denominator, multiply both sides of this equation by 2. That gives us 5z is equal to 30. And then from here, and I've seen from the poll results now, most of you all at this point definitely got it. Last step is to divide by 5, and that gives us z is equal to 6, and choice D for done. Moving on to the next question on test day. Great work here, folks, going through this linear equation example. Great stuff here. Let's take a look at our second key algebra concept, and that deals with quadratic equations. And you might remember this from good old school math. The Nemaga FOIL, which refers to when you're multiplying things that have a parentheses sort of on the inside and a parentheses on the outside. Two things that are being multiplied together to get to multiply out that expression. Multiplying these two factors, use FOIL by multiplying out the first terms, the outer terms, the inner terms, and then the last terms. The first terms is going to be x and x, so that's going to give us the x squared. The outer terms, x times -3, x times -3, and then the inner terms, 2 times x, is going to give us -x. And then the last terms, 2 times -3, is going to give us -6. So that's how we multiply out to create that quadratic equation. Now, the reverse of that, to find the factors of a quadratic equation, we're simply going to reverse FOIL that. So if we have something like this, x squared plus 5x plus 6 is equal to 0. And we want to figure out the two factors that go together to make x squared plus 5x plus 6 equals 0. Well, here's the easy part. Type this into the chat. What two things do you multiply together to get x squared? What are the two things that you're going to put together to get the x squared term? And yeah, of course, and I see lots of people putting in now x and x. So we can literally fill that in the first spot. And now here's the slightly harder part. Then to figure out what the other numbers are going to be, you ask yourself this. What two numbers will add together to get the middle term, in this case 5, and will multiply to get the last term, in this case 6. Type that into the chat, please. What two numbers add together to get 5, or positive 5, and multiply together to get positive 6? Which two numbers will give you that? And yes, of course, it's 3 and 2. So x plus 2 and x plus 3, and there's your reverse foiling. That's the factored form of how to simplify that expression. Let's take a look at our second example. Once again, we're going to open up the poll. If you have an answer, take a look at number 2. What is the sum of the two solutions for x in the quadratic equation x squared plus x minus 56 is equal to 0? So great. We just saw how we can take that quadratic equation and try to simplify this. So let's factor that equation first. So again, the first step, well, set up the x's, right? Now, the second step is this. In this case, what two numbers add together to get the middle coefficient and multiply together to get the number at the end? And be careful, folks. Type it into the chat here. Here's a little hint to make sure you're not falling for any traps. Look at the signs. Look at the signs of those terms. We have 1 basically on the front, and we have negative 56. So what two numbers add together to get positive 1 and multiply together to get negative 56? And those two numbers are going to be negative 7 and positive 8. So we've got x minus 7 and x plus 8. So far, so good. Now, here's the thing. Notice the other part of this equation said equals to 0. So type this into the chat for me real quick. And I see a lot of people, some people actually maybe falling for the temptation of going towards a common misstep here. But let me ask you this. Why is it so important when we're multiplying two things together, making them equal to 0? Type that in. What happens when you multiply two things together and you get a result of 0? What has to be true about one of those things? What has to be true about one of those things? When you're multiplying two things together and you get a result of 0, what has to be true is that at least one of those things has to be equal to 0. So in this case, x minus 7 is going to equal 0, or x plus 8 is going to equal 0. Therefore, what is x equal to? X is equal to 7 or negative 8. But we're not done just yet, because what's the question asking for? It's asking for the sum of the two solutions. So our final step is to simply add the two solutions we've got. 7 plus negative 8 is going to give us negative 1. Answer choice H is your correct answer here. Great work for those of you who got choice H there. A lot of folks fell for choice J because what's the common mistake here? A lot of times people see the negative 7 and the positive 8 when they're factoring. It's like, oh, okay, so that's what x is, right? Be careful. When you're factoring, you're just setting up what the factors are. But then to know what x is equal to know what the solution is, you set each of those factors equal to 0. So therefore, x minus 7 is 0 and x plus 8 is 0. Okay? Great work on this question, folks. Let's take a look at our next topic that deals with proportions and ratios. So ratios and proportions often are written in this format of A colon B. But honestly, A colon B, in terms of math, in terms of calculating, doesn't feel quite that useful, right? Like 3 colon 4, 4 colon 7. Like, what does that mean exactly? So often, when people look at ratios, they often put it into a fractional form. So this is the alternative, A over B, okay? A over B, okay? So a couple of things you want to ask yourself when you're looking at a proportions question or a ratio question. Is this some sort of part-to-part ratio, or is this some sort of part-to-whole ratio? For instance, are they talking about the number of dogs to cats, or are they talking about the number of dogs to pets? Because like pets would be counting all of them, right? Like all of the different animals. And then secondly, is the question asking for a new ratio or is asking for a total number? And then secondly, if you have a ratio, if you only have a ratio, you can find the multiples but not the actual total. So for instance, if I said to you, for every 2 apples, there are 3 bananas. Well, do you know for sure how many apples you have? Do you know for sure how many bananas have? No. You know for sure that if there are 2 apples, you have 3 bananas. But if you have 20 apples, what else would you know from that? If the ratio of apples to bananas is 2 to 3, but I tell you there are actually 20 apples, what would you know about the number of bananas? There we go. Following that same ratio, you'd have the number of bananas being 30. So that is certainly gold star worthy. So we're gonna light up some gold stars. I know Eli's a big fan of the gold stars. I am too. So there's our first gold star. We're gonna kind of make you guys earn those gold stars because gold stars are special, and we're gonna see, and hopefully we'll rack up some gold stars as we're going through. So there's our one little preview gold star, everybody. So remember that when you have just the ratio, you don't know the actual number. But if you have the ratio and one number, then you can figure out the other number, and you can also figure out the total. Let's take a look at this and see if we can earn our first big gold star. Take a look at number 3. Once again, the poll is open. Take a look at number 3. The value of S is directly proportional to the value of T. When S is equal to 9, T is equal to 36. What is S when T is equal to 30? So here's the thing. We see this wording here that says directly proportional. What is that a fancy way of just saying? When it says S is directly proportional to T, what do you do with the S and the T to make our lives easier to try to get through this particular question? What do we do with the S and the T here? And here, what we're going to do is when it says S is directly proportional to T, it means we're going to set up that ratio of S over T. Good. So now S is equal to 9, T is equal to 36. So we're going to set 9 over 36 is equal to S over 30. And then from here, what we can do is, remember, we can cross multiply this to get 36S is equal to 270. And then our last step here, folks, divide both sides by 36. S is equal to 270 over 36. And I hope you guys are using that calculator for this. I would not want you to try to manually figure this out. But when we punch it into our calculator, we're going to probably 7.5, which is going to lead to 15 over 2, which is, of course, answer choice B. B for boom. Look at that. Gold star. Actually, you know what? This one demands a little bigger gold star. Nicely done, folks, for this question here that talks about, again, just understanding what directly proportional means. Okay, just going to set up the ratio. S over T has a direct relationship with something else in the question as they talk also about S and T. Great work here, folks. Gold stars for everybody. Go grab that gold star. Literally take it from the monitor. No, don't do that. Don't do that. All right, let's take a look at our next concept, which deals with rates and using rate calculations. So rates can be any proportion of basically one unit to another. So for instance, there are examples like, for instance, distance and time, right? Like when you're I know a lot of you guys in high school right now, maybe some of you guys are dreaming of the day that you can drive a car for the first time. And of course, speed is an example of a common rate, which is the distance divided by the time. So for instance, if you are driving, let's say 30 miles per hour, 30 miles is the distance, 1 hour is the time, and that's your rate. So remember this equation here. Rate is equal to distance over time. And the same equation, but just by multiplying both sides of that first equation by time, will give us this. Distance is equal to rate times time. I know some of our Kaplan colleagues love to refer to this as the DIRT equation. So if that helps you remember this, use it. DIRT. Distance is rate times time. So DIRT equation, if that's helpful. So just a quick way to remember, if you're solving for the distance, DIRT, distance equals rate times time. And then, of course, the other way to format this is if you were to divide both sides by the rate, then you'd have distance divided by rate is equal to time. So 3 different ways of saying the same equation. So depending on which of these 3 parts you're solving for, set up the equation appropriately. Okay. And the other thing to note here is that when you see rate problems on the ACT, you're trying to set up for a specific unit. So look at the question itself, look at the information there, and set up what the known rate is as a proportion to solve for the thing you don't know. So for instance, if they say, oh, I went 30 miles in 2 hours. Well, I'm looking for the speed because I have the distance and the rate. Or if they say, oh, I went 60 miles per hour and I drove for 2 hours. Well, in that case, you have the rate and you have the time, you can figure out the distance. So let's take a look at our example here. Take a look at number 4. The time it takes to complete a certain job is directly proportional to the number of units produced. If it takes 22 minutes to produce 18 units, how many units are produced in 33 minutes? So here's an example of a rate, but we also notice, again, going back to something we saw earlier, this concept about directly proportional. So we're going to set up our proportion here using rates, using the time that we have and the 18 units. So the units we're producing and the time. So if we set this up here, 22 minutes to produce 18 units is equal to 33 minutes over however many units that you have. And then from here, you can simplify by cross multiplying that equation there. 22 times u is equal to 33 times 18. And again, this is where you break out the calculator, folks. There's a little challenge to making sure you're not holding on to that calculator for dear life as if that's like the only friend you have on the ACT. Hopefully by the end of the online prep live program, you'll realize that all of us teachers at Kaplan are your friends in terms of studying for the ACT. But here's the point where you would want to definitely break out that calculator. 33 times 18, and then we're going to divide that by 22. 594 divided by 22 is going to give us a result of 27. 27 units are produced in 33 minutes. And there we go. Choice G, as in great job here. Another big old gold star for you all to share with one another. Share the gold star, everybody. 27 is your correct answer here. Good. Now one other thing, and I think a few folks might have noticed this, is if there's actually a little bit of a simpler way, if you noticed it, and again, if you didn't notice, not a big deal, just make sure to do the straightforward math, but to go from 22 to 33, you're going to add half, right? Half of 22 is 11, so you're going to add half of that to get the new number. Well, the same thing you do on the bottom. Type it into chat. What's half of 18 equal to? What's half of 18 equal to? Not a trick question. So that's going to be 9, and we're going to add 9 to the 18, and look at that, folks. That gives us our 27. So I know Stephanie mentioned my calculator is my best friend. So if your calculator is your best friend, obviously I don't want to disrupt the great relationship you have with your calculator. So use your calculator if it's easier for you. But again, there are multiple ways to sort of see how we can get to our answer even faster. Great work on this. Let's take a look at a couple of other examples here. Let's take a look at one or two more examples before we look at our next category. Take a look at number 5. If 5z plus 7 is equal to 12z minus 2, then z is equal to what? So we want to find what z is equal to. Type it into the chat. What's the first step here to ultimately get z by itself? What's the first thing we need to do with this equation in order to get z by itself? I'm seeing a lot of folks mentioning, yeah, you got to move the z's over to the other side. We can do that by subtracting 12z to both sides of the equation. And then we can also move the 7 over to the right side. I think we're so used to like putting the variable on the left side and then the number on the right side, and that's fine. You know, you want to be consistent about this, right? So move everything with the variable over on the left side, move the numbers over to the right side, and then what do we get? Negative 7z is equal to negative 9. Now, here's the thing you want to be careful of. What are you dividing by in this equation? Type that in. What are you dividing by in this equation to get z by itself? And this is where you want to be careful. You're not dividing by 7. You're dividing by negative 7. So z is equal to negative 9 divided by negative 7, and that's going to give us 9 over 7, which of course, is answer choice A for awesome. Great work on this one. Saw a few folks put in choice B at first, and that's again, you just want to be double check. You just want to make sure, a lot of people put down choice B because it's like, oh, the -7 on the left side, the -9 on the right side, that simplifies to 7/9. But remember that last step, divide both sides of the equation by what's in front of the variable. Let's take a look at number 6 here. 2s plus 3 times 2s minus 3 is equivalent to what? Let me ask you guys this first. Let's see if we're already on the road to becoming ACT experts. What is this question ultimately testing you on? What's the mathematical concept that we covered earlier that they're really seeing like, okay, how well do you understand this mathematical concept? What's the concept here that we're really looking at? And yes, we're looking at multiplying those expressions. We're looking at FOIL. But there's one other thing here. If you're sharp with FOIL, or if you notice something about FOIL, well, if we multiply those expressions out by using FOIL, the first terms, 2s and 2s, is going to give us 4s squared. The outer terms, -6s, and the inner terms, 3 times 2s, +6s. And then the last terms, 3 times -3 is equal to -9. But tell me this in the chat, and this is one of the most fun parts of math, to be honest. What's the thing you can simplify here? What's the thing that actually goes away? And the thing that goes away is those middle terms. Why? Because this is actually an example of A plus B and A minus B. A plus B and A minus B. And you might remember, and type this into the chat as well, when you multiply A plus B times A minus B, one of those special quadratics, see if you remember it, folks, what does A plus B times A minus B simplify to? Or when you multiply those out, what does that equal? And that's going to be equal to, and there it is, the difference of the squares. The difference of the squares of those terms. So the square of 2s and the square of 3, and find the difference. And which of those leads you to that? And absolutely, that's going to be simply 4s squared minus 9, which is choice H. Great work on this. So again, you can shortcut this a little bit by just saying, you know what? I just want to find. I recognize the A plus B and the A minus B. This is an example of the difference of the square. So if you square each of those terms, then subtract, and that will simplify it a little bit. If you didn't see that, obviously you can still do the FOIL, but it would be good to practice that so that you can save yourself a little bit of time. You might be thinking to yourself, well, I only saved like 5 seconds, right? 5 seconds can be a big deal, right? 5 seconds can be the time it takes just to double check a slightly more difficult problem, giving you another couple of points maybe on the ACT math test. One more in this set before we move on into the second part of the math lesson for today. Take a look at number 7. At a glass workshop, 60 pounds of composite are required to produce 15 pounds of glass. How many pounds of composite are required to produce 3 pounds of glass? So again, before you start digging into the question, tell me, what's the math topic here? What's the concept that the test here is asking you, how well do you know this? How sharp are you on the skill? How ready are you in college to apply this particular skill? What's the skill here that they're testing us here? And that skill, of course, is by setting up the ratios. There we go, ratios, and setting up the proportion, right? So not just one ratio, right? Because one ratio would just be like A over B. We've got 2 different things going on here, right? So if we set up that ratio, 60 pounds over 15 pounds, right? 60 pounds of composite required to produce 15 pounds of glass, 60 over 15. And then we're looking for how many pounds of composite are required to produce 3 pounds of glass, x over 3. Now, you can cross multiply this. 15 times x is equal to 60 times 3. So when we do that, 15x is equal to 180. And then our last step is to divide both sides by 15. But even before I light up the correct answer here, there's one other thing we could have done here. Look at the 60 on the top and the 15 on the bottom. I think a lot of you guys say like, yeah, Arthur, I saw that. I definitely wanted to do that. And that's great if you noticed it, because we want to keep our calculations as simple as possible. What is 60 over 15 going to simplify to? To just make our lives a little bit easier, to make the calculations a little bit easier, 60 over 15 is going to give us 4 over 1. So 4 over 1 equals x over 3, and then you can cross multiply that, and that'll give you the same answer, x is equal to 12. Choice A for awesome work on this section. Great stuff here, folks. Really great, great stuff here. Again, don't be afraid to use that poll function that you see on the right side of the screen next to the chat button to continue to participate with us. And again, let us know if you have any questions about any of the concepts that we've looked at so far. Don't hesitate to reach out directly to us and just be like, hey, what did Arthur mean by that? Because that's one of the great things about the online class. We've got lots of teachers standing by to answer any questions that you might have. All right, let's take a look at the next part of our lesson, which talks about key geometry concept. You know what? I just realized even before I move on to that next one, yeah, you know what? You guys crushed this section. So that is not just going to warrant one small star becoming big, but that's actually going to warrant this one big star and a circle of little stars all falling under the star universe. This is like literally each one of you gets a star. Literally each one of you gets a gold star that kind of gets its power source from the larger star. And yes, that might have been a science fiction reference. Let's take a look at our next section, everybody. It talks about geometry. So a couple of key geometry concepts that we want to make sure that we are solid on so that we can tackle ACT geometry questions. First thing about triangles. The interior angles of a triangle always, always, always add up to 180 degrees. If it doesn't add up to 180 degrees, it's probably not a triangle. It's not a triangle, actually. Like 3 sides of a triangle always add up to 180 degrees. The area of a triangle is found by multiplying the base by the height and then dividing it by 2. Or the common formula that I think a lot of you are probably familiar with, area is equal to 1/2 times the base times the height. But just to remember, just one other thing just to note here is that when you're looking at a triangle and what the base and what the height are, just remember this. Base and height are always perpendicular to each other. The base, for instance, if the base is a flat, like horizontal line, the height is a vertical line. It has to go directly, and the base and height have to be perpendicular to each other. They have to form a 90-degree angle. If the 2 lines don't form a 90-degree angle, you don't use those as the base and the height. See what other lines you can use that would form a 90-degree angle inside the triangle, or even just as part of the triangle. And the last concept to remember about triangles is that for all right triangles, good old Pythagorean theorem. And I know a lot of you are like, oh my gosh, I saw a Pythagorean theorem like 2 years ago. This is really going to come up again? Yes, it is, because this is, again, just showing, again, the basic formulas here and key concepts where Pythagorean theorem applies for all right triangles and only for right triangles. So if you don't have a right triangle, don't use Pythagorean theorem. But if you do have a right triangle and you're looking at something to do with the sides of that right triangle, think Pythagorean theorem. A squared plus b squared equals c squared. A and b are the legs. C is the hypotenuse. And also, in particular for right triangles, look out for the 3, 4, 5 right triangle, the 5, 12, 13 right triangle, and also, if you want to jot this down as an extra note here, multiples of these. So for instance, type this into the chat. Let's say you had a right triangle where 2 of the sides were 30 and 40. You can use the Pythagorean theorem, 30 squared plus 40 squared equals c squared, but wait a minute. Do you notice that if a right triangle had 2 sides of 30 and 40, it would have to fall under a specific pattern. And the hypotenuse then would be equal to what? Yeah, please don't use the Pythagorean theorem for this one. 30 squared is 900, 40 squared is 1600, 900 plus 1600 is 25. You don't do that. Don't do the actual test. In that case, of course, the triangle's hypotenuse would be equal to 50 because it would follow that 3, 4, 5 pattern. So when you see a right triangle and you see sides of the right triangle, see if you can find the pattern first before setting up the Pythagorean theorem. Let's take a look at a question that deals with triangles. Take a look at this example here. And once again, poll is open if you think you have an answer for this one. What is the degree measure of the smallest interior angle of DEF below? And we have this triangle DEF, and the three angles are labeled. D is 4x plus 16, E is x plus 2, and F is 2x plus 15. So let's think carefully about this. Here's the information we have of these three angles labeled with these algebraic expressions. So at first, like, oh, wait, what? Algebra? No, I thought this was geometry. Wait, why did they make us do algebra? Here's the thing. What do you know for sure about the relationship with 4x plus 16 and x plus 2 and 2x plus 15? What's the thing that has to be true regarding all three of those angles and how those three angles are related to each other? What do you know about 4x plus 16 and x plus 2 and 2x plus 15? These three angles together must add up to 180 degrees. So that's going to be our first step here to set up that equation. X plus 2, 2x plus 15, 4x plus 16 is equal to 180. Now here, when we combine like terms, remember on the right side, you just set it equal to 180. They've got to add up to 180 degrees. And then from here, when we combine those like terms, x, 2x, and 4x, and 2, 15, and 16, that's going to give us 7x plus 33 is equal to 180 degrees. 180 degrees. And then the next step here, again, this is now an algebra question all of a sudden, but hopefully a not too challenging algebra question here. If we subtract 33 on both sides, we get 7x is equal to 147, and x then is equal to 21. And I see a decent number of you guys put down choice F here, but let me ask you this. Are we done? Is this question asking us for the value of x? Take a look at that question again. Is it asking us for the value of x? No. It's asking us for the smallest interior angle of triangle DEF, the smallest interior angle. So 21 is not going to be our answer here. We need to, well, here's the thing. A lot of people are tempted by, oh, well, now I have to plug in x is equal to 20 to all three of them, right? Well, wait a minute. We only care about the smallest one. So if you notice here, x plus 2, 2x plus 15, 4x plus 16, just think logically here. Which of those three is going to be the smallest? X plus 2 or 2x plus 15? Or 4x plus 16. I see Jacqueline, I see Kyla. Yeah, that's that ooh moment, like, oh, now I get it. And that's a great moment to have because now you're like, all right, I'm not going to fall for that again. I'm going to make sure I take that extra step to make sure I can make a real difference in my ACT score. We're going to plug into the x plus 2 angle. That's going to be the smallest one. So our last step, 21 plus 2 is equal to 23. Answer choice G, as in great job here. Nicely done, folks. So again, a couple of different things here, especially with these geometry questions. They love bringing up algebraic concepts as in these geometry questions. So that's why once you take the information in the geometric figure, set it up as an algebra question, and you are going to be done with this one. And you're going to move on to the next question, even more confident of your ACT skills. Let's take a look at our next concept that deals with parallelograms. Parallelograms are four-sided figures. We have two pairs of congruent sides and angles, and all the angles in that figure must add up to 360 degrees. Now, one way to remember this, just as a quick shortcut, if this helps, is, well, a parallelogram, if you think about it, you can cut this into two triangles. And since each triangle is 180 degrees, well, two triangles will give us 360 degrees. So that's a quick way to remember that. And you can also use this for even bit more polygons with more sides to them. So for instance, a pentagon actually forms 3 triangles. You can use a pentagon, basically cut up a pentagon into 3 equal triangles. Then each triangle is 180, so 3 times 180 is 540. So it's a similar concept there. Instead of just having to randomly memorize, okay, triangle's 180, quadrilateral's 360, pentagon's 540. Like that's just a quick way to help you remember that, okay? So all angles in a parallelogram add up to 360 degrees. And again, the big thing to note here, in this diagram, if you see here, here's our base, which we labeled B. Don't fall for the temptation of saying, well, yeah, isn't it like the 2 sides? Isn't it 2 sides? So isn't this the height? But if you notice, A and B are not going to form a perpendicular. So what's the height going to be? The height's going to be whatever this distance is, from the top to the bottom, straight up and down, from the top to the bottom, whatever that distance is, that's going to be your height. The area of a parallelogram is simply area is equal to base times height. So think about what I just mentioned about a triangle. And do you notice the difference between the formula for area of a parallelogram versus area of a triangle? What's the one difference between these 2 formulas? Area of a triangle versus area of a parallelogram. Type into chat. What's the one difference between these 2 formulas? The one difference is that, well, in the triangle formula for area, you have the 1/2. But in the parallelogram area, you don't have the 1/2. Because, again, a parallelogram is basically 2 triangles. So you double up whatever the area would be of the triangle to get the parallelogram. So let's take a look at this example here. Take a look at number 9. And again, poll is open if you want to, if you have an answer for this one. Take a look at number 9. Parallelogram ABCD is drawn below. If triangle ABE is a right triangle, what is the area of the shaded region AECD? Well, let's think about this, folks. And I know, and you can even type it in if you're like, well, AECD is some sort of figure, right? Like, again, this might be a little bit more of an advanced figure, but type into chat if you know what it's called. I'll give you a little hint. Starts with a T. But what kind of figure is AECD? Right? It's like it's a 4-sided figure, but wait a minute. It's like 2 sides are parallel, but then the other 2 sides kind of like one goes inward, one's a straight line. There's a fancy term for that if you remember it, and that is the good old trapezoid. But then you're like, oh, wait, no, Arthur, no. The trapezoid area formula is weird. There's like that B1, B2 thing, and you add them, and then you do something weird with that. Like, all right, let's forget that for a second. And let's go with what we've got here. We've got the parallelogram. We've got the parallelogram ABCD. And the things that we know about the parallelogram is, well, one side is 10, but then one of the sides is 13. And the side here, or not even the side, but the line labeled AE, type this into the chat. What does AE represent in this parallelogram? What does AE represent in this parallelogram? This 6 represents the height of this parallelogram. So look, we've got a base and we've got a height. Well, at the very least, we can start with what the area of the parallelogram is. Area of the parallelogram is 13 times 6, which is 78. So that would be the area of the parallelogram. But since we're looking for the area of just the shaded region, well, let me ask you this. Logically speaking, what do you know about the area of the shaded region compared to the number 78? Is the area of the shaded region going to be 78? The area of the parallelogram is 78, but the shaded region is smaller than that, right? It's smaller than that, so that means the area of the shaded region has got to be less than the area of the parallelogram. So with that in mind, then, there are a couple answer choices we can eliminate. We know it can't be 78, and we know it's got to be smaller than 78. So therefore, So therefore, we can also get rid of the answer choice that's bigger than 78. We can get rid of 130. And look at that. Now we've got 3 answer choices remaining. So the area of the parallelogram is 78. But we need to get rid of something. In order to get the shaded region, type it into the chat. What's the thing we have to get rid of from the parallelogram in order to get the shaded region? What's the thing we have to get rid of? And yes, there it is. I see a few folks noticing, well, wait a minute. There's that triangle thing, right? AB is equal to 10, AE is equal to 6. Something to do with that triangle. Tell me, what else do you notice here? In this right triangle, we know one side is 6. We know the hypotenuse is 10. What is this side going to be then? What's that missing side going to be in that triangle? And again, you can use Pythagorean theorem, or if you remember, one of those special right triangle proportions. What is that missing side going to be? That missing side is going to be 8. There we go. Yes, there it is. 6, 8, 10 is the special right triangle. Awesome work there. Very nicely done. So that missing side is going to be 8. And now we can figure out the area of the triangle. 1/2 times 6 times 8, which is equal to 24. So the area of the triangle is 24. Last step, hardest part of the question. Wink, wink. How do you find the area of the shaded region? You know the area of the parallelogram is 78. You know the area of that right triangle is 24. How do you find the area of the shaded region? What are you going to do with those two numbers? What are you going to do with those two numbers? You are simply going to subtract them. 78 minus 24 is equal to 54. Choice C is your correct answer here. Great work on this question. Saw most of you guys, we saw a good majority of you guys put down choice C there. But again, avoid something like choice D, which is kind of like the answer to a different question, right? So you just want to make sure that you're reading that question carefully. Good stuff here, good stuff. All right, let's take a look at another key geometry concept that deals with rectangles and squares. So rectangles are a specific type of parallelogram. We said that parallelograms are 4-sided figures with 2 pairs of congruent sides, but rectangles are 4-sided figures, 2 pairs of congruent sides, and they form 4 right angles. Forming 4 right angles. So they're all still equal to 360, but for rectangles, each angle is equal to 90. And like a parallelogram, like a parallelogram, each of the 4 angles must add up to 360, so each one is going to be 90 degrees. And the area of a rectangle, in this case, it's just the length times the width, because the length and width are going to be perpendicular. So since you already have that 90-degree angle there for a rectangle, in those cases, you can just use the straight line on the bottom and the straight line going up and down. You can just use those to find your area. And then squares are a specific kind of rectangle. So notice we have our little progression here, right? We start with quadrilaterals, which are just 4-sided figures. Then you've got parallelograms, which are 4-sided figures where we have pairs of congruent sides that are parallel to each other. Then you have rectangles that are 4-sided figures, parallel lines, and all of them are 90 degrees. And then you have squares, like the most specific kind, where you have 4-sided figure, 90 degrees, and all sides are the same. Okay, so let's take a look at number 10. Again, the poll is open if you want to take a shot at this question. Let's take a look at this one together. In this diagram, point A on square ABCD is at the center of the larger square EFCG. If DG is equal to 8, what is the area of the square? What is the area of the shaded region in square inches? So interesting here, right? Because we've got, again, very similar to the question that we saw earlier about like, okay, a shaded region. And we want the area of some sort of shaded region here, right? So let's start with what we know for sure. We know that DG is equal to 8, so we can fill that in. But also, here's the thing. Well, you might be at first like, well, that's all they gave us, right? There are no other numbers here. But it says point A on square ABCD is at the center of the larger square. Type this into the chat. What do you know about those sides then? Or what do you know about, for instance, you see how GD is 8, but if A is the center of that square and it's forming basically another square here, what is going to happen basically with each of those sides there? What do you know for sure about each of those sides in that square? If it says A is at the center, yes, there it is. All sides are going to be equal. So just as DG over here is 8, well, that means that down here it's also going to be 8, which also means over here it's going to be 8, which means over here it's going to be 8, which means over here it's going to be 8. So basically that smaller square inside the larger square is all sides are going to be equal to 8. Well, if we know all the sides of a square, well, we can figure out at least what the area of that square is, but we can also figure out the other sides, the sides of the larger square, is going to be equal to 16. Because again, notice how we have the 8 over here, but then the 8 over here, and the 8 over here, that's going to give us 16 total. Well, what do we do with these numbers here? If we find the area, remember the formula for area, length times width. So the area of the larger square is going to be 16 times 16, which gives us 256. And the area of the smaller square, the square inside the larger square, that's just going to be what? 8 times 8, which gives us 64. And then last step here, and type into the chat, what do you do with these two numbers in order to find the area of the shaded region? If you're looking at that shaded region, think about what you need to get rid of in order to find what's left over. What do you do with those two numbers? We're going to subtract those two numbers. 256 minus 64 is equal to 192, and choice H is your correct answer. H for hoorah. Okay, I have no idea what that meant. But there's your answer there, right? Again, take the larger square, get rid of the smaller square, and that's what you're left over with. The shaded region is basically the difference of those two squares. Find the area of the larger square, find the area of the smaller square, and that leads to, obviously going to lead to big time ACT gold stars there. There you go. Good work here. Grab that star when you have a chance, and let's take a look at our next example here, dealing with trapezoids. So we are going to do a quick review of, again, that more complicated figure that deals with trapezoids, dealing with trapezoids. The base of the trapezoid, or the two bases in the trapezoid, the top and the bottom, are never the same, right? That's by definition. A trapezoid is a four-sided figure where two sides are parallel to each other, but the two sides that are parallel to each other are not the same length. So you have base 1 and you have base 2. And if you remember the area, and you can type it into the chat if you want to just dust off those trapezoid skills, but the area of a trapezoid is going to be, at first it looks kind of similar to some of the formulas that we saw before, but with a little bit of a twist. But the sides of trapezoid can be the same length, but they don't have to be necessarily the same length. But remember, the bases are never the same length. And then the formula for the area of the trapezoid is going to be in this format. Area is equal to base 1 plus base 2 times the height divided by 2. Sometimes people have heard this, and you can give me a quick yes, or you can tell me how you've learned this formula before, but just to make sure that it's the same format. But I remember learning as 1/2 times the height times the sum of the bases, or you might remember as height times the average of the two bases, if you've heard it in those slightly different formats, but they mean basically the same thing. Add up the two bases, divide by 2, and multiply by the height, or find the average of the bases, multiply that by the height, or 1/2 of the sum of the bases and the height. However you might remember the area of the trapezoid formula, use that, but basically it just follows that format there. Okay, so let's take a look at this example here. Again, poll is open if you want to, if you have an answer for this one. Take a look at number 11. If the given dimensions of the trapezoid in the figure below are in meters, what is the area of the trapezoid in square meters? Well, tell me this. In order to know the area of the trapezoid, what are the things we need? First, type that in. I want us to go through this a little bit more step by step because there's something in this question that might throw us off at first. What do we need in order to find the area of the trapezoid? What are the parts of that formula where you need that you need for the trapezoid? So one of the things he asked, one of the things is you need the bases. So let me ask you this. Are we given the bases in this diagram? Are we given the bases in this diagram? And you may have thought, well, wait a minute. I'm given one of them, right? I'm given the 6 over here, but I'm not given the other one. Wait, where's the other base? I need this thing. Wah wah. I'm sad. I don't know where's that other base. So we're missing that, but we also know that in not just the bases, we need the height. Now here's again where you want to be careful. What's the height of this trapezoid? Is it the 12? Or is it the 13? Is the base of the height of this trapezoid, is the height of this trapezoid the 12, or is the height of this trapezoid the 13? And there it is. Yeah, the height is going to be 12. Remember, the height is whatever's perpendicular to the base. So the 12 is going to be the height. So far we know the height is 12, one of the bases is 6, and we need the other base. And then you might be thinking, oh man, that 13 is kind of distracting us. Do we even need that 13? But that 13 is actually going to be really helpful because if you see here, a lot of people see the trapezoid, but you might see another type of figure here. Remember our formula for area of a trapezoid, 1/2 times the sum of the bases times the height. But you also notice here, right, so we have our base, we have our height. The height is equal to 12, the base equals 6. But if you see the special right triangle, the 13 here is a big step to remember. Wait a minute, isn't there that 5, 12, 13 thing? Yes, there is. This is, if we draw in the height over here, this is going to give us a hypotenuse of 13. One side is 12. And then what is the other side of that triangle going to be? That's going to be 5. So we know that little section over here is going to be 5. And we know what this distance over here is going to be because it's going to match what's on top, the 6. So tell me this in the chat. What's the other base equal to? What is that other base going to be equal to? It's going to be equal to 11. Now we've got our two bases and we've got our height. And now at this point, we're just going to plug into our trapezoid area formula. 1/2 times the sum of the bases, 6 plus 11, times the height, which is 12. And we've got 1/2 of 204, which is going to give us choice A, 102. A for awesome work on this question. Great work on this one, folks. Let's take a look at one other, couple more, maybe one or two more concepts here. Let's take a look at circles and some of the key concepts to remember about circles here. First, the radius of the circle is the distance from the center to any point on the circle itself. The diameter is basically twice the radius. It's always going to be twice whatever the radius is. So for instance, if here's a quick example of a circle, actually let's make that a slightly darker color so you can see it a little better. There we go. If you see that circle there, the radius is going to be the distance from the center of the circle to any point on the circle itself. So for instance, this is a radius. The diameter is twice the radius. The diameter is basically from one end of the circle through the center and over to the others from one end of the circle through the center to the opposite end of the circle. So if you notice here, the diameter basically makes up 2 radii. 2 radii, not radiuses, that's not the right word for it, but radii. The diameter is made up of 2 radii, so that's where we get our formula. Diameter is d is equal to 2r. Diameter is, again, twice the radius. Okay. Second thing we're going to take, second thing we'll take a look at the formula for the circumference. Circumference of a circle is basically just a fancy word for the perimeter, the distance around the circle. And the distance around the circle is equal to 2 pi r. And then lastly, the area of the circle is equal to pi r squared. Take the radius, square that number, and multiply that by pi. So let's take a look at our example here. Take a look at number 12. Again, the poll is open if you want to try this question here. Take a look at number 12. 2 circles have diameters that are in a 2-to-1 ratio. So again, notice, a little bit harder now. This question's a little bit more challenging. They're incorporating more of those math concepts. So 2 circles have diameters, 2-to-1 ratio. The area of the smaller circle is equal to 36 pi. How much larger is the area of the larger circle than that of the smaller circle? So wait, whoa, that wording's a little bit weird here. So let's go through this step by step. First, there's one thing you can definitively figure out. The area of the smaller circle is equal to 36 pi. Well, if you remember our formula for area of a circle is equal to pi r squared. So what's the radius going to be? We can figure out what r is based on just knowing the area of the smaller circle. Area is equal to pi r squared. So 36 pi is equal to pi r squared. You can type into the chat, what is the radius of this circle going to be? What's the radius of the smaller circle going to be? That radius of the smaller circle, yeah, you're going to just take the square root of 36 to figure out what the radius is. Radius is equal to 6. Now, as a super picky math note, if you see r squared is equal to 36, technically r is equal to positive 6 or negative 6. But in this case, we don't care about r is equal to negative 6 because we're talking about distance here, right? We're talking about the distance of stuff, and distance is never going to be a negative number. It would be really weird if you ever gave directions to someone. Yeah, you walk negative 6 blocks that way. I hope you never do that because that's just mean. That's just cruel. It's kind of funny, but it's kind of cruel too. So radius is simply going to be the square root of 36, which is equal to 6. Okay? And Tristan, you made a great point there. Why this doesn't really seem like geometry so much as like a logic type question. I think that's a great point you made there. We'll dig in a little bit as we keep going here. So the radius is equal to 6. Now the question talks all this stuff about diameters, right? 2 circles have diameters that are in 2-to-1 ratio. So first, if the radius is 6, the diameter then is just going to be 2 times r, which is equal to 12. So let me ask you this. If the diameter of the smaller circle is 12, what's the diameter of the larger circle? And remember, the thing we want to note here is that the 2 circles have diameters that are 2-to-1 ratio. So if the smaller circle has a diameter of 12, what's the diameter of the larger circle? There we go. The diameter of the larger circle is going to be equal to 24. So now if the diameter of the larger circle is equal to 24, well, what else can we figure out about that larger circle? Again, thinking about all those formulas we saw regarding circles and how circles work. If the diameter of the larger circle is 24, what else can we figure out? Let me ask you that first. A little bit more open-ended question, but let's see how well you've tested yourself on those skills dealing with circles. The radius is going to be simply half of that, right? Because diameter is equal to 2r. So the radius is going to be equal to 12. And one other thing we can figure out about this circle, if we know the radius, what else do you know? You know the area. Area is equal to pi r squared. So when we plug in 12 for r, the area of the larger circle is going to be 144 pi. Great. So the area of the larger circle is 144 pi. But let me ask you this. Are we done? it's like, it's sometimes the most frustrating thing, right? When you're looking at math questions, you're like, I know the skills, I know them, I remember these formulas, I remember doing them, I feel sharp on them, feel confident on them. But the thing is, you want to always remember to answer the question that's actually being asked here. What's being asked here? How much larger is the area of the larger circle than that of the smaller circle? And that, again, I think for a lot of people, that's that light bulb moment, like, oh, right? The area of the larger circle is 144 pi. We're given that the area of the smaller circle is 36 pi. And one more time, everybody, I know, Diana, sometimes it feels like we're never done, but that's the thing. You always, once you answer the actual question that's being asked, that's when you know you're done. What do we do with these two numbers here? We've got 144 pi and 36 pi. We're going to subtract those two. 144 pi minus 36 pi is going to give us 108 pi. Answer choice J is your correct answer. Masra, yeah, that's the same reaction I would have given also if I gotten this question wrong, because I was like, wait, I know the formulas. What? Oh, snap. What? Right? So again, make sure that you're always answering the question we ask. Always double check. Always double check and be like, all right, is this what they're asking for? I just solved for X. Is that what they're asking for? Oh, wait, no, they're solving for Y. They're asking for Y. Or in this case, are they asking for the area of the larger circle? No, they're asking for how much bigger is that bigger circle than the smaller circle. So you have to remember to include that one extra step here of subtracting those numbers. All right. And then perimeter, volume, and surface area. Our last category of math topics here, dealing with perimeter, which is first, basically the sum of the lengths of all the sides of any shape. Just basically adding up the sides. That's what perimeter refers to. Volume for different types of figures. If you have a rectangular solid, the volume is equal to length times the width times the height. Stephanie, I'm so sorry. I didn't mean to make you laugh out loud, but I'm glad if you're enjoying this, that's a good thing. That's a good thing. The rectangular solid volume is equal to length times width times height. And for a sphere, so a sphere is basically like a three-dimensional circle. Like, for instance, a basketball would be an example of a sphere, right? A circular three-dimensional object. The volume of the sphere is 4/3 pi r cubed. And then the volume of a cylinder. So for instance, a soup can would be an example of a cylinder, right? Circle on the top, circle on the bottom, three-dimensional figure. That's a cylinder, pi r squared times the height. Remember these volume formulas for ACT math test questions. And then the volume for a cone, 1/3 pi r squared times the height. Notice the one big difference between a cylinder, for instance, like a soup can, and then a cone. Like, for instance, a traffic cone, right? The only difference between these two formulas is what? The only difference is the 1/3. So if you can kind of remember, cone is 1/3 of a cylinder, well, then that'll make actually remembering those two particular formulas a lot easier. And then lastly, surface area formulas. First, the surface area of a rectangular solid. A rectangular solid could be like something like a box, basically, right? On a box, you have the top and the bottom, you have the left and the right, and then you have the front and the back, right? Oops. Yep, the front and the back. So you have 6 sides of a rectangular solid. So basically, the surface area is adding up the areas of those 6 sides. 2 times LW, 2 times WH, 2 times LH, basically adding up the 6 surface areas to get the overall area of the rectangular solid. And then for a sphere, the surface area, 4 times pi r squared. And then for a cylinder, a little bit more complicated formula there, but 2 pi r h plus 2 pi r squared. That's your formula for the surface area of a cylinder. One way you can picture the surface area of a cylinder is, again, picturing like a soup can. The surfaces of the soup can are the top circle and the bottom circle, right? So that's where we get the pi r squared, or the 2 pi r squared, right? The top circle and the bottom circle. So that's 2 pi r squared. And the 2 pi r h if you picture like a soup can, and let's say like you're carefully tearing off like the label on the soup can, and you kind of peel off the soup can label. Type it in the chat. Just picture it. What's the shape of that label going to be once you peel it off the soup can? If you're taking the soup can label, you're peeling it off, what would be the shape of that label? The shape of that label is going to be a rectangle. So the rectangle is going to have basically two things, the base and the height, which are 2 pi r and the height. The 2 pi r is basically all going around the circle, and the height would be from the top and bottom of that cylinder. Okay, so again, it's a little bit more complicated formula there, but again, these are the important formulas you'll need to remember regarding three-dimensional figures. Let's take one more formula to remember. The cone, surface area of a cone, pi r s plus pi r squared, and just to note, the s there is the length of the slant. So the slant is basically how slanted is that cone going from the top to the bottom. So let's take a look at our question here, number 13, that says, in the diagram below, a sphere with a radius of 4 inches is inscribed inside of a cube so that the sphere touches all 6 faces of the cube. What is the volume of the cube in inches? So we're given that this sphere has a radius of 4. Has a radius of 4. So from there, what else do we know about this sphere? If the radius is 4, what else can we figure out? And I know this looks like a really complicated question, but we are going to make this so much more efficient for us by just noting the one important thing here. When the radius of that sphere is 4, think back to basics. A sphere is basically a three-dimensional circle. So if the radius is 4, what else do you know about that sphere? Well, you can figure out the diameter, right? If the radius is 4, radius is always half the diameter. So the diameter is going to be equal to 8. So like, okay, well, all right, great. The sphere, the diameter is equal to 8. But now think about this. What does that 8 also represent? The 8 represents, right? The 8 represents the diameter of the sphere, but it also represents something else. What does that 8 also represent? Look at that figure to give you a little bit of a clue here. The 8 is not just going to represent the diameter of the sphere, but since it says the sphere touches all 6 faces of the cube, basically that 8 is also going to be not just the diameter of the sphere, but the side of the square. Almost like basically like if you take that 4 from like one end all the way to the end, like it's basically going to form basically going to be the length of that cube, the length of the entire cube. So each side of that cube is also going to be 8. So if each side of that cube is equal to 8, type it into the chat. What do you do to find the volume? What do you do to find the volume of this cube? If you know that one side is equal to 8, well, the length is 8, the width is 8, the height is 8. We're just going to multiply those two numbers together. 8 times 8 times 8. And again, please don't do this in your head, folks. Don't do this in your head. 8 times 8 times 8 is going to be equal to 512. Choice C is your correct answer. Nicely done. We saw a few folks put in 128 pi. 128 pi actually represents something very different in terms of the figure. Not so much the cube, but something to do with the sphere itself. So remember, what's that question asking for? It is asking you for the cube. So something to do with that cube, all right? Great stuff here, folks. So this was just a foundational, just to get you the foundations of, to get you on the path to a really strong ACT score and on the path to getting into the colleges and universities that you are targeting as your top schools. So in our remaining time here, we're going to just take a quick look at, again, so this is just basically a quick preview of like what to expect on the ACT. And just remember that this is just one quick snapshot of the ACT Kaplan Online Prep Live program. So with this program, you'll get access to the official ACT practice, right? This is actually a really exciting time for us with the ACT and Kaplan as we're working together to get as many of you many students and many test takers prepared for the ACT. So you're gonna get official ACT practice and also live instruction, like what we just did here today, through this same website, through the same website setup, and also on-demand instruction. So it's just like kind of like if you've ever, use like Netflix or use HBO or whatever, right? You just want to load up a movie on your own schedule. We also have on-demand instruction, which is basically like you can access lessons anytime, not just at scheduled times, but also you can watch the recordings. Now, I think the live instruction is actually pretty fun because it's a little bit more interactive, but the point is you get access to all online instruction anytime you want, including personalized study plans and using some of Kaplan's best and brightest ACT experts, and me. They let me here today. But in all honesty, again, you see the teachers that have been helping you guys out in the chat. Some of our very best ACT instructors, and you'll see some of these folks, by the way, in the online prep live program as well. So the program itself is at only $179 for a 6-month subscription, which means for a lot of you guys, if you're thinking about taking the ACT, especially for those of you who are thinking about taking the ACT more than once, this is great because that'll cover you for maybe 1 or 2 or maybe even 3 ACT exams. And also the other big thing to note, if you're eligible for a fee waiver on the official exam, you will also get this program for free. So just because we want to be able to give everybody an opportunity to study for the ACT well, to get the ACT score that you're looking for, okay? We include over 2,400 ACT practice questions and 2 full-length ACT practice tests and 4 what are called short forms, so slightly shorter versions of official ACT exams. So you get tons of practice with this extra program. Tons of extra practice with this program. You also get 25 hours or more than 25 hours of unique instruction across all the different concepts, question types, all the different lessons that will cover everything on the ACT. In addition, we're going to have like life skills sessions. These are really great sessions, honestly. We've seen a little sneak peek at all of these about setting goals for yourself, about time management, managing test anxiety, because these are the things, again, they're not just useful for the ACT. They're useful for finishing up your junior or senior year, or for those of you who are even underclassmen right now, your sophomore year, your freshman year. All these additional instruction is available as well, including live class times that are convenient. We want to make this as convenient for you guys to be able to access all of your online materials. And again, on-demand recorded instruction for ultimate flexibility. And you'll get tons of breakdowns of how to, not just how you did on a practice test, but more importantly, what you need to work on next. Because it's one thing to be like, well, I took this last practice test and I got a 27. Great. I went up 5 points. Awesome. The real thing you want to know, of course, is, okay, well, what do I do now to get a 29? What do I need to do now to get a 31? What do I need to do now to get a 32? That's the real important stuff. So not only can you get reports on your performance, but it'll show you basically the areas that you need to practice a little bit more, but also the areas that you're doing really well on. Because let's face it, if time is limited, maybe you don't want to waste time on a lesson where you're like, I already know that. No, you want to really get to the specific stuff that you want to work on. So that's again, another big part of the ACT Kaplan Online Prep Live program. As I mentioned, lots of our top ACT experts are being part of this new program that we're doing for the ACT. We're really excited about this program. I don't know if you can tell, I'm really excited. I know if you were here last night with Eli, he was super excited about working with all of you folks who are going to be taking the ACT. So again, we have our on-camera teachers like myself, and we have all of these off-camera teachers. And like I said, the off-camera teachers are just as expert at the ACT as I am. You will see folks like Boris, you will see folks like Stephanie, you'll see all these folks who are working off-camera right now, but they'll be also teaching our ACT lessons as well. And again, one of the great things is you probably noticed that we have a chat function, lots of private questions, right? Sometimes you just don't want to ask that question in quote unquote public when like everyone can see what question you're asking. But if you're like, hey, what was that one thing that Arthur said? And then the off-camera teachers are the ones who are able to answer those questions. So you're like, oh, cool, now I got it. Awesome. And that's the way that you're gonna have, that's the way to really get the most out of these classes, by making sure that you're utilizing, not just listening to me, but also by following along with the materials, but also using those off-camera teachers to help you answer any questions that you might have. So I saw a great question earlier from, I think it was a Parry. He said, how do I sign up for the Online Prep Live program? So here's the thing. So the usual registration, the most of you, when you register for the ACT exam, you have the option of adding the Online Prep Live classes, the Online Prep Live program. So it's available as a bundle, basically. You can bundle them together when you register for the ACT. Now, some of you might be thinking, well, wait a minute, I already registered for the ACT because I'm taking the test in October. You can add on the Online Prep Live without registering for new tests. So I don't want you to be like, well, I was going to take the test in October, but maybe I should take the test in December or later on because now I want to get this extra class. You don't need to do that. You can buy the Online Prep Live program separately. And actually what we're doing now, because the Online Prep Live program, we're going to start offering it to folks on Friday. But in the first few, basically, if you want to upgrade your program, if you're using ACT Online Prep, but you want to upgrade to the Online Prep Live, which includes the live instruction and teachers like myself working working with you through ACT questions, you can upgrade to the program for only $75 rather than the regular upgrade fee of $150. So may want to take advantage of that if you're already in the ACT Online Prep program. So just basically tacking on the word live to get access to more instruction, more online videos, and so on and so forth. So remember, Online Prep Live goes on sale this Friday. So go to the ACT website. Remember, the ACT website is the place to go if you want to sign up for the ACT Kaplan Online Prep Live program. And you should see some sort of button below to give you more information about purchasing the Kaplan Online Prep Live program. And again, we hope to see you. I can't tell you how excited we are at Kaplan. I know working with lots of the different teachers we have for the ACT, for instance, Boris and David and Katie and Stephanie, all these folks who are working together to be like, this is a real great opportunity to be able to help so many more students. I know a lot of times people are like, but I don't want to take a class because I'm worried it's going to be boring and I'm not going to have time for it. This is the program that's really going to give you an opportunity to really hone your ACT skills, to show those colleges that, hey, I really want to go to your school, and heck, you should probably admit me to your school because here's my ACT score. Booyah! And then whatever score that you've got. Hopefully an improved score, significantly improved score after taking the ACT Kaplan Online Prep Live program. So again, Online Prep Live goes on sale this Friday. If you have any other questions, stick around just for maybe like a couple minutes. We'll answer any other questions. Otherwise, again, we hope to see you in a class very soon. And as a friendly reminder, tomorrow, on this same website, same time. So tomorrow, Wednesday, September 21st, Eli will be back to cover the ACT reading test. And then I will be back on Thursday to cover the ACT science test. So just like we did here, just going to go through the basics, the foundations of these particular sections of the test. So if you have friends who are taking the ACT, tell them to come on by tomorrow or to tell them to come on by Thursday to get a little bit of extra practice with the ACT. But for now, thank you all very much. Have a wonderful rest of your night. And hopefully we'll see a lot of you tomorrow as well. Thank you all very much. And have a wonderful rest of your night. Take care, everyone.